Welcome to the DX Today podcast, where you get facts, not hype. The first thing we want to establish today is that this deep dive is entirely about facts, not the breathless hype that has dominated the tech headlines for the last 2 years.
Right.
Today, we are undertaking a critical mission, cutting through the noise surrounding artificial intelligence. Specifically, we're looking at the sharp, unmistakable schism between what companies are promising they can do with AI
And what they're actually delivering in the operational reality of 2025.
It feels like we've been in this generative gold rush for a while now.
It is a necessary correction, and the data really demands it. We have absolutely been in a generative gold rush, and it's been fueled by, massive capital expenditure and this promise of autonomy.
But that excitement seems to be hitting a wall.
It's crashing headlong into enterprise reality. Our sources for today's deep dive, they detail this operational reality, contrasting the robust, quiet success of what we're calling practical AI with the surprisingly high and often, frankly, catastrophic failure rate of these over-marketed autonomous systems, the Agentic Hype.
So our mission in this deep dive is to give you, the listener, the definitive data-backed position. We're going to unpack the facts that show sustainable enterprise value in 2025 lies almost exclusively in practical AI.
Which is really defined by, data analysis, simple process automation, and administrative assistance, the basics that work.
Exactly. And we're going to show conclusively why the promise of agentic hype, these systems that claim to function as fully autonomous digital employees, is, well, failing.
Failing commercially, technically, and economically. It's a systemic issue.
And we should be clear, we are not relying on marketing brochures for this.
No, absolutely not. No keynotes. We are looking at cold, hard production data. We are referencing financial audits like the ones released by global giants such as JPMorgan Chase. And we're really drilling down into the technical failure rates of these multi-step autonomous systems.
And when you look at that combined data, what's so fascinating here is how clearly it supports a single definitive verdict for any enterprise leader trying to, allocate capital today.
Be practical, not hyped.
Exactly. Be practical, not hyped. We are going to trace the technical and the economic reasons why a staggering 95% of autonomous initiatives just stall out.
And that proves we've moved past this era of, let's call it, reckless experimentation and into a moment of sober assessment. The budget realities are kicking in.
Okay, so let's unpack this. If you just look at the surface-level adoption metrics, things look pretty robust.
They do.
Our sources confirm that roughly 78% of organizations report using AI in at least one business function. To the casual observer, that sounds like the AI revolution is fully underway and, everyone is winning.
Right. It paints a very rosy picture.
But our sources say this figure is highly misleading. It's a surface-level success. So what is that 78% figure actually hiding?
It's hiding the enormous difference between a proof of concept and production at scale. That 78% means someone, somewhere in that organization, ran a pilot. Maybe they summarized 5 documents using an LLM, or they implemented a simple classification algorithm in one single department.
So it's not transformation.
They haven't achieved systemic transformation. Not even close. The market is absolutely at a critical inflection point right now. We're moving from what was previously indiscriminate experimentation.
Where companies just threw money at any shiny object.
Exactly. And now we're in a phase of sober assessment, of real-world value, of reliability, and, maybe most crucially, of governance.
And this whole movement has given rise to a pretty brutal condition in the industry that we really need to define. It's called pilot purgatory.
It sounds suitably painful for IT budgets, and believe me, it is. The pilot purgatory condition is a phrase identified by sources like MIT's State of AI in Business 2025 report. It describes the widespread stagnation of AI initiatives at the proof of concept stage, the POC stage.
So they can build a demo.
They can create a compelling demo in a sandboxed environment, sure. But when they attempt to move that solution into a reliable, governed, and scaled production environment, where it has to integrate with legacy systems and comply with real-world regulation, it just stalls indefinitely.
And the data point here, the failure rate for these stalled projects, it's truly staggering. It's the kind of number that should dictate corporate spending for the next few years.
It is staggering because it shows a profound lack of technical viability for these complex applications. The data indicates that 95% of all ambitious AI initiatives stall.
95%.
95. Fewer than 5% of companies successfully move these custom AI solutions, particularly the complex ones, into production environments.
Wow.
And when we drill down into where this attrition is happening, we find it is heavily, heavily concentrated in attempts to deploy autonomous or agentic capabilities.
The systems that promise to replace human decision-making entirely.
Or just operate without constant supervision. That's where the failures are piling up.
So if I, as a leader, approve a massive project that says, AI, go autonomously manage this complex customer service relationship, I have a 95% chance of seeing that budget just evaporate.
Into a non-deployable proof of concept. That's the reality.
Yeah.
It is a massive systemic problem.
And that's the operational reality of 2025.
It is, because those autonomous ambitions inherently introduce massive complexity and unpredictable failure points, which we'll detail later when we discuss the brutal math of what's called error cascading. The systems are just too fragile for the enterprise.
And this is exactly where the contrast between the two approaches, really crystallizes.
It is. The organizations that avoided that complexity and the associated hype, they saw immediate returns.
The practical AI group.
Exactly. Conversely, a major study by Google Cloud highlights that 74% of executives achieved a clear return on investment and ROI within just 12 months.
74%.
When they chose to focus on clearly defined, bounded tasks, things like productivity assistance, data analysis, or simple deterministic process automation.
So this is the great bifurcation of the AI market.
It is. One path is a 95% probability of failure, leading to budgetary purgatory.
And the other is a 3/4 probability of success in under a year.
That risk differential is what's driving capital reallocation across every single major industry right now.
That distinction is just paramount. So for you, the listener, trying to allocate resources or just understand your company's tech strategy, we need to move past the ambiguity of the term AI itself. We have to clearly define the technologies that are consistently delivering value versus those that are simply driving the hype cycle.
To cut through that ambiguity, we have to provide precise operational definitions to distinguish these two paradigms. And let's start with the systems that are actually delivering that 74% success rate.
Okay, lay out the parameters of success for us.
Practical AI refers to systems designed to assist, analyze, or automate specific well-bounded tasks. And the key word here is bounded.
Bounded.
They have to operate under human supervision or within very strict deterministic frameworks. They leverage the powerful pattern matching of machine learning and the synthesis of large language models, but, and this is critical, they explicitly avoid independent agency.
Can you give us an example?
Think of a classic successful example, a fraud detection system. It flags a suspicious transaction, but it requires a human to sign off on actually freezing the account.
Okay.
Or, as we'll discuss, a document summarization tool that drafts the text but requires a human lawyer to review and sign the final memo.
So practical AI is a force multiplier. It's giving the human worker say, a 10x tool, but it is fundamentally not a replacement worker capable of independent judgment.
That is the crucial differentiator. Now, contrast that with agentic AI, or autonomous agents.
Right.
These systems are defined by their attempt to replace human judgment. They're designed to perceive their environment, reason about complex goals, plan multi-step actions, and then execute those actions without human intervention.
And the promise here, this is why it captures the imagination, is that they act as employees.
That's the marketing line. That they can navigate disparate software interfaces, make independent business decisions, and handle complex end-to-end processes from start to finish. This is where all the headline-grabbing hype lives.
Okay, let's put the two systems side by side, because the operational difference in how they handle complexity is really what defines their success or failure.
Absolutely.
Our sources provide this phenomenal side-by-side comparison that addresses the structural difference. Let's start with supervision.
Okay, if we look at supervision and structure, practical AI operates on structured data, and it requires constant human oversight. It's built on a deterministic framework.
Meaning its outputs are predictable and verifiable.
Exactly. Or it has a mandatory human in the loop to maintain that governance. Agentic AI, conversely, is all about autonomous goal setting. It is fundamentally probabilistic.
So the model decides the next step based on a calculation of likelihood.
Right, and that unpredictability is inherently unreliable when you're dealing with enterprise complexity.
And that leads directly to the killer metric, reliability. Practical AI aims for high reliability, right?
Yeah.
Meaning 99% plus uptime and accuracy.
In its distinct components, yes. You mentioned fraud detection. If your full system is only 80% reliable, you are losing massive amounts of capital.
Either through false positives or missed fraud.
Yeah.
Both are costly.
Exactly. And because agentic AI is probabilistic and multi-stepped, it's plagued by low reliability. It is constantly subject to unpredictable error cascading.
Which we'll get into.
And the standard LLM problem of hallucination, where the model just invents facts or impossible next steps. The reliability difference isn't marginal, it's existential for enterprise trust.
And that low reliability is why the production status is so skewed. It's what's fueling this pilot purgatory.
It is.
Practical AI is in mass adoption.
Yeah.
We see it governing JPMC's internal LLM suite. We see it driving developer efficiency through copilot tools like Cursor. Agentic AI, conversely, is still firmly in the experimental stage. It's marked by these high-profile commercial failures like the Rabbit R1 device, which promised autonomy but
Delivered fragility. Or the failed autonomous software engineer, Devin.
Exactly.
And this commercial reality is forcing a fascinating strategic shift among the AI vendors themselves. We're now seeing vendors who promised pure autonomous agents start rebranding their structured automation processes as agentic workflows.
So a little bit of marketing magic.
It's a linguistic pivot. It's a tacit admission that the pure, fully autonomous agent has failed to deliver commercially and technically. They're trying to slap the agent label on systems that are fundamentally just practical AI to maintain investor interest in what's becoming a cooling market.
That leads directly to the critical role of governance, especially in regulated industries. For you, the listener working in, say, finance, healthcare, or legal analyst, refer to this as the compliance cost cliff. You have to ask, is the potential benefit of this autonomy worth the existential cost of a regulatory violation?
And for regulated industries, the answer is a resounding no. The risk of an ungoverned AI, even if it performs brilliantly 8 out of 10 times, absolutely outweighs any implementation friction. The cost of a major compliance failure is existential to a large financial institution.
So how does practical AI successfully navigate that compliance cost cliff?
Practical AI builds what we call a trust moat. It treats governance as foundational infrastructure, not an afterthought. Because it keeps AI as an augmentation tool, that human-in-the-loop requirement. It can be audited, reviewed, and controlled at every single step.
So if the AI hallucinates in a draft memo,
The human reviewer catches it before it's sent to a client, which limits the legal exposure. You have verifiable outputs.
but autonomous agents, they just don't allow for that guardrail, do they?
Precisely. Autonomous agents inherently create a profound trust gap. Their probabilistic, multi-step decisions result in these opaque black boxes. If an autonomous agent executes a complex trade or approves a specialized medical claim and it fails, how do you audit its reasoning?
You can't.
You can't reliably reconstruct its full decision path because the model's internal weightings informed all the subsequent actions. That opaqueness renders them completely unsuitable for mission-critical and regulated roles. The moment the decision process becomes opaque, that compliance cost cliff becomes too steep to climb, and that's where pilot purgatory begins.
The financial reality check we need to have here is that the hype narrative so often obscures the fact that the most profitable AI implementations, they're often the least glamorous.
Absolutely.
We're talking about boring AI that delivers hard dollars, not glossy keynotes about an AI replacing the CEO.
We have to look at the substantiated financial value that exists outside of the generative AI headlines. That's where the real money is being saved and made today. Predictive analytics, which is basically the original practical field of AI, it continues to be the workhorse.
And the highest ROI category in this field is remarkably unsexy: fraud detection.
It is.
Unlike soft metrics like time saved, this is hard dollar savings by preventing capital loss.
That's right. And it's a pure practical AI success story because it is so bounded, so focused on data analysis. By 2025, 75% of financial institutions are using AI specifically to detect fraud and improve risk management.
They're not trying to get the AI to reason about market psychology.
No, they're asking it to look for numerical deviations. That's it.
Can we anchor this with a specific, hard financial example to really demonstrate the scale of this success?
Absolutely. And you don't have to look any further than JPMorgan Chase, which we're going to use as our core case study today. Their implementation of proprietary systems like NeuroShield has been instrumental in reducing scam-related losses, unauthorized transaction issues, and improving operational efficiencies.
And the number.
Our sources confirm that this single implementation, focused entirely on practical risk mitigation, has saved the bank a staggering $1.5 billion.
$1.5 billion in hard savings. That is the absolute antithesis of a stalled pilot.
It is.
What's the precise mechanism behind that success that makes it practical AI?
Yeah. The mechanism is pure data analysis using supervised learning models, which are really the backbone of practical AI. It's pattern recognition, and it's incredibly fast. The model analyzes billions of transactions in real time, looking for anomalies, behavioral deviations.
So it's not trying to guess what a good trade is.
Not at all. It's using historical data labels, this was fraud, this was not fraud, to train the model to identify deviations from normal human behavior. This minimizes the uncertainty of a probabilistic model because the goal is so bounded. Classify the transaction based on historical evidence. It's identifying patterns that are invisible to humans, not reasoning or negotiating like an agent would.
And we see that same focused, deterministic approach translating into massive capital savings in logistics and retail too, right? Supply chain optimization is another one of those areas where boring intelligence wins.
Absolutely. This is another area where bounded data analysis translates directly into massive capital savings. Predictive inventory systems at major retailers like Amazon and Walmart are leveraging AI to manage extreme complexity. We're talking lead times, geopolitical risk, shifting tariffs.
All of it.
And it's leading to a reliable 10 to 15% reduction in carrying costs.
And for a global retailer, that's not small change.
For a global retailer, that represents hundreds of millions of dollars that go straight to the bottom line simply by having the right stock in the right place at the right time.
So they're utilizing AI to analyze demand, weather patterns, and global indicators, but, and this is the key, they're not asking the AI to autonomously redesign the whole logistics network or sign new vendor contracts.
No, they're using it for simple process automation driven by data intelligence. A company like Zara, for instance, utilizes AI to analyze these complex variables, sales data, real-time weather, economic indicators, to optimize the distribution of their clothing lines.
It's about ensuring availability and reducing waste.
Exactly. This optimization is driven by data intelligence, not by some autonomous agent trying to run a warehouse and make unpredictable tactical decisions.
Okay, now let's pivot to the generative AI space because this is where a lot of the excitement is focused.
It is.
But even here, the successful applications seem to be the most passive and practical ones, and that means we have to talk about Retrieval-Augmented Generation, or RAG.
RAG is the most widespread, successful, and importantly, the most governable implementation of generative AI in the enterprise in 2025. It solves a crucial dual-pronged problem.
What kiss?
Standard LLMs inherently hallucinate, and they lack any knowledge of private, proprietary enterprise data. You cannot ask a public LLM about your company's Q3 internal legal findings because it hasn't been trained on that proprietary data.
And the practical solution RAG offers is elegantly simple because it introduces a layer of fact-checking and security.
It is. A RAG system doesn't ask the AI to know the answer. It separates the source material from the generator. The RAG system first searches a secure, proprietary vector database, which is populated only with validated company documents, and retrieves the most relevant passages.
And only then does the LLM get involved.
Right. It then asks the LLM to only summarize or synthesize an answer based specifically on those retrieved enterprise documents. It effectively handcuffs the boundless creativity of the LLM to the factual reality of the company's own proprietary data.
That shifts the AI's role entirely. It goes from being a creative generator to a fact-constrained curator.
Exactly. The primary use case here is administrative assistance at a massive scale, querying internal knowledge bases, drafting memos based on specific internal reports, summarizing complex regulatory updates, or quickly finding an obscure legal clause in a 500-page document. It raises the baseline competence of the entire workforce by making institutional knowledge immediately accessible and accurate.
And why is this considered practical AI? Is it because it's a passive system that can't actually take action?
That's a huge part of it. It's passive. ARJA provides information. It gives the lawyer the summarized regulatory updates, but the lawyer still drafts, reviews, and files the document. The human is the executioner.
And that limits the blast radius of errors.
It absolutely limits the blast radius. If the RS summary is slightly inaccurate, the human reviewer catches it. Compare that to an autonomous agent that, based on a hallucinated fact, autonomously executes a billion-dollar transfer or sends a definitive, unreviewed client memo. That boundary of passive assistance is everything for enterprise reliability and governance.
The software development sector provides perhaps the clearest, most recent dichotomy between what works and what fails. The market has, it seems, absolutely and decisively chosen assistance over autonomy.
The evidence here is compelling, and it's financial. The winner is the copilot model, tools that act as administrative assistants to developers. These tools are driving massive, verifiable commercial growth precisely because they adhere to that practical AI model.
And the growth figures for these tools are just stunning. They really validate the demand for assistance.
They are. Cursor, for instance, a copilot tool by AnySphere, reached $100 million in annual recurring revenue ARR in under 12 months.
Wow.
Our sources cite this as one of the fastest-growing SaaS companies in history, and you see similar success with tools like Windsurf, which focuses on keeping the developer in a flow state by assisting with documentation and coding refinement.
So what's the fundamental functionality that makes these tools work where the autonomous agents seem to stumble?
They are purely assistants. They autocomplete code, they suggest refactors, they help search documentation right inside the developer's workflow, but the core responsibility remains with the human.
The human developer is the ultimate authority.
Always. Reviewing, accepting, or rejecting every single suggestion before it's integrated into the codebase. This is administrative assistance applied to software engineering, and that constant human-in-the-loop governance is why adoption is so high.
What are the numbers there?
89% of developers reported using generative AI in their daily work by 2025. It's nearly universal.
Okay, now let's contrast that reliable commercial success with the hyped autonomous engineer.
The loser in this scenario is Devin, the AI marketed as the first AI software engineer.
Right.
The promise was pure agentic hype. Devin would take a high-level request, say a JIRA ticket for a bug fix, and autonomously research the issue, write the code, debug it, and deploy the fix to production without any human intervention.
And what was the reality when it was faced with real-world tests? Because we can't rely on the marketing demos. We need to look at standardized benchmarks.
The reality was brutal, and it proved the weakness of multi-step autonomy. Independent benchmarks, specifically on the SWE bench dataset, which is a standardized test set of real-world complex software issues taken from GitHub, showed Devin had a success rate of only 13 to 15%.
Just 13 to 15%.
On real-world issues, it failed constantly. It was plagued by hallucinations, getting stuck in loops, or proposing these impossible solutions that simply couldn't integrate into the target environment. It just couldn't manage the multi-step complexity required for genuine autonomy.
And this commercial failure led to a massive strategic pivot that really validates our entire thesis.
Yes. Cognition, the company behind Devin, ultimately acquired Windsurf, a successful, practical copilot tool. This move, as our sources point out, was a critical, tacit admission that the fully autonomous model, the one that generated the massive valuation and all the media buzz, was not commercially viable or reliable enough to sustain the company on its own.
So they had to immediately start selling a successful, practical assistance tool.
To generate verifiable cash flow and just to justify their runway. It was a business necessity.
Okay, to really drive home the practical AI thesis, we need to deep dive into JPMorgan Chase. They're so often cited as the ultimate AI success story in finance.
They are.
So if they're winning and generating over $1 billion in value, they must be using the most effective technology, and we need to understand exactly what that technology is.
And when you analyze JPMC's implementation, the scale of their success is directly attributable to their strict adherence to pragmatism. They are not chasing autonomous agents. They are building highly governed, human-centric tools.
Let's start with their LLM suite. It's the centerpiece of their generative AI strategy.
It is. It's a proprietary platform that provides secure, governed access to third-party models like OpenAI and Anthropic. This ensures they reap the benefits of the technology while mitigating all of those regulatory compliance risks we talked about.
When you hear proprietary platform for secure LLMs, it sounds very sophisticated, like something that might be running the bank autonomously behind the scenes.
It sounds that way, yes.
So what is the operational reality of this tool?
The reality check is that it's essentially a highly governed enterprise ChatGPT wrapper.
A wrapper.
It's a sophisticated administrative assistant. Employees use it to draft emails, summarize complex documents, and securely generate ideas. But here is the key element. It is entirely human-prompted and human-reviewed.
And we cannot emphasize enough what it doesn't do.
It does not autonomously execute trades, it does not approve loans, and it certainly does not transfer funds. The critical decision-making remains strictly with the employee.
And the scale of deployment here is the ultimate proof that this governed, non-autonomous approach is essential for regulated industries.
It's the ultimate validation of the trust mode. The platform has been deployed to over 200,000 employees.
Wow.
That's 60 to 70% of the bank's entire workforce. This massive successful adoption is only possible because the tool is non-autonomous and governed. Because they keep the human in the loop and control the access points, JPMC successfully mitigates the risk of hallucinations, ensures compliance with strict banking regulations, and prevents proprietary data from leaking into external models. They prioritize security and governance over pure, risky autonomy.
And the bank's own leadership confirms this orientation, right? They see the AI as elevating the human, not replacing them?
Yes. Derek Waldron, JPMC's chief analytics officer, is very clear on this. He describes the tool as aiming to democratize AI for employees. The goal isn't replacement, it's augmentation. They're giving the existing employee a more efficient tool set to maximize their output rather than hiring a digital replacement who may only succeed, 35% of the time?
Another JPMC product that generated huge media buzz was Index GPT. Again, the name itself implies a sophisticated autonomous system making complex decisions.
It did, and it was often conflated in the media with fully autonomous robo-advising or trading agents. But when you look at the actual mechanism, the plumbing, it is, again, a sophisticated data analysis tool and simple process automation, carefully decomposed into reliable steps.
How does it actually work in practice, and how does JPMC ensure it remains practical?
It works by dividing the task. It first uses GPT-4, the linguistic model, specifically to generate comprehensive keyword lists for complex or emerging investment themes, things like esports venture capital or sustainable aquaculture technology.
So the creative brainstorming part.
Yeah, that's the part.
Yeah.
But crucially, once that keyword list is generated, it's passed to a completely separate, specialized natural language processing model. That second deterministic model then scans vast amounts of news, filings, and proprietary data to identify relevant companies that fit the theme.
So they're using the LLM for the one thing it is very good at, language synthesis, and then passing the result to a specialized, deterministic model for the data extraction and validation that requires high reliability.
Precisely. It automates the laborious research phase of thematic investing, which is traditionally labor-intensive and manual for human analysts. It doesn't manage portfolios, it doesn't predict stock movements, and it doesn't execute trades. It automates data gathering and sorting. It is a textbook practical AI implementation.
A combination of data analysis and simple process automation.
Exactly.
We can't talk about JPMC's success without bringing up the older but foundational success story of Coin, because it perfectly illustrates the sustained value of process automation.
Coin, or contract intelligence, predates the generative boom, but perfectly illustrates the bank's long-standing be practical ethos. Coin utilizes machine learning, specifically intelligent document processing IDP, to parse highly complex commercial loan agreements.
And IDP, just to clarify, is essentially structured optical character recognition. Correct. It's not reasoning about the contract's fairness or anything like that.
Exactly. IDP is basically highly structured OCR. It's not trying to negotiate, it's just trying to turn a complex legal PDF into structured, searchable data fields. And the impact of this highly deterministic task was immense.
This is the famous number.
It famously reduced the workload equivalent of 360,000 hours of annual legal work to mere seconds by automatically extracting key data points and clauses from agreements.
And that reduction in hours isn't just a time saving, it's a massive risk reduction.
It is. The task is deterministic and bounded. The goal is not negotiate a better contract. The goal is find the termination clause date or extract the interest rate. It accelerates human review, ensuring that the human lawyer can review 100 contracts for missing clauses or compliance errors instead of just one. It validates that reliability and huge ROI come from the simplicity and boundedness of the goal.
So, to synthesize the JPMC success, the bank reports $1.5 billion in verified business value from its AI initiatives.
Right.
And our deep dive reveals that value is derived almost entirely from fraud prevention, which is data analysis, and efficiency gains, which is administrative assistance. The key takeaway is clear. They are the success story because they ignored the hype and focused only on highly governed practical augmentation.
which naturally leads us back to the failure side of the equation. If the promise of autonomous agents is so exciting and, they have unlimited time and resources, why is the real-world failure rate so consistently high? Why does it keep forcing companies into pilot purgatory? The answer is often not a simple software bug, but a fundamental architectural challenge rooted in statistics and mathematics.
This is the critical technical concept we need to fully understand. Tell us about the brutal math of error cascading.
Error cascading, or compound error probability, is the primary technical reason autonomous agents fail in production environments. An agent needs to string together multiple steps: research, plan, execute API calls, interpret results, decide the next step, and the fundamental problem is that LLMs, being probabilistic models, are never 100% accurate at any given step.
So it's like having an assembly line where every single station has a small chance of error. A failure at station 2 ruins the product, regardless of what happens at station 7.
Precisely. A small failure early on dooms the entire mission. But let's look at the formula our sources provided. The probability of total success in a multi-step task is the product of the individual success probabilities. Let's be generous and say a model is 90% accurate at each step, meaning 1 in 10 steps fails.
Okay, that sounds pretty good on its own.
It does. But if an agent has a 10-step task, say, research a vendor, check their credit, draft a contract, send it to legal, the probability of completing that entire workflow successfully is 0.9 to the power of 10.
Which means the entire autonomous workflow succeeds only about a third of the time.
It results in a success rate of only 34.8% for the entire workflow. If you increase the complexity to 20 steps, the success rate plummets to just 12%. The math simply does not scale to enterprise reliability standards.
A single error in step 2 just propagates to all the subsequent steps.
It does. And studies on multi-agent systems confirm that these upstream errors are 3 times more prevalent than intrinsic reasoning errors. So it's the coordination and sequence, not the raw intelligence, that's the critical failure point.
That fragility completely explains the 95% pilot purgatory failure rate we talked about earlier.
It does.
The system might ace a demo where the environment is perfectly controlled, but once it faces the messy complexity of a real-world API environment, it just falls apart.
That's the reality. Beam AI's 2025 review found that a staggering 90% of AI agents fail within 30 days in production environments.
90% in 30 days.
Specifically due to these reliability issues and context loss. They might ace a quick demo, but they fall apart when faced with the complexity of a real enterprise API environment. This is why Gartner predicts that 40% of agentic AI projects will be canceled by 2027. The math just doesn't support the promise of reliable, autonomous, multi-step execution.
Let's talk about the highly publicized claim that dominated headlines. Klarna's AI agent replacing 700 human agents. To many people, that sounded like true autonomous replacement, the end of jobs.
It was a cornerstone of the agentic narrative, yes. Klarna announced that their AI assistant handled 2.3 million conversations, 2/3 of their customer service chats, and drove a $40 million profit improvement. The initial message was that the AI had successfully taken over a huge chunk of the workforce.
But if we apply the practical AI lens to this success, what do we find? Was this a true agent? Or was it a highly effective process automation tool?
We find that the agent was primarily a customer service chatbot, handling Tier 1 support. It was structured automation. It handled routine, low-complexity queries like refunds, returns, and FAQs.
So simple process automation.
It's excellent at filtering the ticket queue so that human agents can focus on the high-value, complex, or exception problems.
So it was a highly effective filter, adhering to the practical AI model, not a replacement agent capable of complex, empathetic interaction.
Exactly. And the fragility of relying too heavily on it showed up very quickly. Subsequent reports showed that Klarna's CEO admitted to overusing the AI.
Overusing it.
The AI's inherent lack of empathy and occasional inaccurate responses in complex cases led to significant customer frustration. This forced the company to pivot back and start hiring humans again for the more nuanced, complex relationship management tasks and specialized financial advice.
The lesson here seems clear. AI is excellent at practical tasks, like deterministic filtering or fraud detection, but it's really poor at complex jobs that require soft skills, nuance, judgment, and complex relationship management.
The moment the query left the bounded, predictable space of Tier 1 support, the probabilistic nature of the model broke down and it started generating customer-facing errors.
And the consumer market offered the most visible, tangible, and often quite humorous failures of the autonomous agent promise. These devices promise to entirely change how we interact with technology, but they fail to deliver.
Both the Rabbit R1 and the Humane AI pin were built around the core, flawed premise that a single autonomous agent could seamlessly navigate all of digital life. They promised to replace the app paradigm with a single intelligent interface.
Let's start with the Rabbit R1. It promised a new technical approach, the Large Action Model, or LAM.
The Rabbit R1 promised a LAM that could use apps for you, like ordering an Uber or initiating a complicated multi-step search query all by itself. In reality, it was quickly exposed as a fancy GPT wrapper that relied on extremely fragile pre-written scripts.
So, not learning on the fly.
No, often using technologies like Playwright to interact with specific web interfaces. It failed to generalize, it was plagued by massive latency, and critics universally deemed it unusable because the scripts would break with the slightest interface change, which is the very definition of a non-resilient, non-autonomous system.
And the Humane AI pin had similar core issues despite its sleek presentation and massive funding.
The AI pin promised to replace the smartphone with a screenless ambient agent. It failed because it was too slow, it overheated constantly, and it failed at the most fundamental requirement of modern digital life, securely integrating with the user's ecosystem.
So it couldn't handle two-factor authentication.
It struggled with secure banking apps, it couldn't handle 2FA. It became a cautionary tale of trying to solve non-existent problems with fundamentally immature agentic technology.
Ultimately, these highly visible flops prove that the concept of universal interface automation, an agent seamlessly navigating all of your apps and secure systems, acting as a true replacement for human interaction.
It's currently a marketing myth built on extremely fragile technology that does not generalize outside of a highly controlled environment.
Okay, so if we connect this technical failure to the bigger picture, the failure of agentic AI isn't just about code. It's driving a profound financial instability in the entire AI ecosystem.
It is. The economics of the AI boom are currently unbalanced, leading financial institutions like Goldman Sachs and Sequoia Capital to sound a very loud alarm.
We've seen this incredible record-breaking investment in infrastructure, data centers, power, GPUs, but the fundamental $600 billion question centers on whether that infrastructure is actually generating equivalent revenue in software sales.
That is the core of the problem, and it was identified starkly by David Kahn of Sequoia Capital. He identified a projected $600 billion gap, potentially growing to $1 trillion, between the massive capital expenditure, the CAPEX, on GPUs and data centers, and the actual revenue generated by the AI software running on that hardware.
So we've bought all the expensive tools, the shovels, but the software companies are not yet selling enough of the finished widgets made by those tools to justify the infrastructure cost.
Exactly. We are selling the shovels furiously. NVIDIA's revenue has exploded to historical highs, but the sustainable AI revenue for the software companies and enterprise implementations has just not kept pace. The economics are inverted.
And it's because enterprises are not willing to pay premium subscriptions for autonomous agents that, due to error cascading, only work 35% of the time.
The reliability is not there, so the commercialization of autonomous software stalls.
So where is the AI revenue actually accruing right now? If it's not the software companies, where's the money going?
The source material is very clear. The vast majority of current AI revenue is concentrated in three main buckets: hardware providers like NVIDIA, cloud providers like Azure and AWS, and consultants who are often paid handsomely to implement the very failed pilots and POCs we've been talking about.
Right.
The actual revenue generated by application software, the products users actually pay for, is lagging significantly. And it's concentrated mostly in practical tools like copilots and creative software, which reinforces the practical AI thesis once again.
This massive CapEx spend would be sustainable if the infrastructure lasted for decades. But we're facing a crucial economic factor known as the depreciation trap, fueled by incredibly rapid technological obsolescence.
This is a massive risk that differentiates the AI boom from previous infrastructure booms. Unlike traditional physical infrastructure like railroads or fiber optic cables, which have a multi-decade useful life, AI infrastructure depreciates incredibly rapidly.
Your billion-dollar data center filled with GPUs today could be functionally obsolete next year.
That's right. And you can just look at the cycle of NVIDIA's chips. The moment the Blackwell B100 chip was announced, it immediately rendered the previous generation, the H100, which companies had spent billions stockpiling, obsolete.
And the performance jump was huge.
The B100 offered 2.5 times better performance. This hypercycle of rapid improvement means that capital invested today loses value extremely quickly if it's not put to immediate profitable use.
Which means companies that stockpile chips without a clear immediate revenue model face what our sources call capital incineration.
That is the perfect term for it. Their assets are losing value faster than they can generate returns. This economic pressure is forcing a crucial market correction. Companies can no longer afford to fund ambitious science project autonomous agents with a 95% failure rate.
They're being forced to abandon the hype.
And focus immediately on practical AI fraud detection, automated coding assistance, RAG systems, because these are the only applications that generate immediate verifiable cash flow to justify the enormous, rapidly depreciating infrastructure costs. The economics are dictating pragmatism.
Okay, so we've established that the fully autonomous model is technically fragile and economically unsustainable. It's due to the brutal math of error cascading and the pressure of the depreciation trap.
Right.
So let's pivot to the constructive solution that the industry is rapidly adopting to survive, moving from these idealized agents to highly controlled workflows.
We need to discuss the necessary linguistic and conceptual pivot that's being pushed by thought leaders like Andrew Ng. They recognize the value of the LLM's ability to reason, but not its ability to execute reliably.
So what's the shift?
They are reframing the discussion from autonomous agents, a noun that implies an entity capable of independent thought, to agentic workflows,
Adjective.
an adjective describing a highly controlled, structured process.
So what is the fundamental distinction in how these systems are architected that prevents that error cascading?
The distinction is control and decomposition. An autonomous agent gets a high-level goal, like write a new software feature, and is told to figure out the steps. As we saw, the result is a high failure rate and unpredictability.
Right.
An agentic workflow, however, starts with the goal, but then imposes a predefined deterministic structure. It says, here is the goal. Here are the defined steps, A, B, C, D. Ask the human for permission at step 3, and retry step 4 up to 3 times if the API returns an error.
That structure takes the complexity of sequencing away from the probabilistic model and puts it back into the hands of deterministic business logic.
It ensures control and reliability. The result is a high success rate because the probabilistic nature of the LLM is contained and governed by deterministic, hard-coded business logic. The architecture, the framework, manages the complexity rather than letting the agent wander unsupervised into an error loop.
The future, then, is orchestration, not pure autonomy. It's about building highly reliable pipelines.
Absolutely. The workflow approach dictates that organizations must use orchestration engines. Tools like LangGraph are excellent examples of this, to hard-code the business logic and flow control. The LLM is only used for specific, bounded subtasks within that logic.
Summarize this document. Extract this date.
Classify this sentiment. Think of the orchestration engine as the complex wiring diagram that ensures the LLM function call happens safely and predictably within the larger system.
So the LLM is just a highly sophisticated yet constrained function call within a deterministic pipeline. It only performs the cognitive task it excels at, and the workflow handles all the risk.
Exactly. And this is the only way to bring reliability back to the 99% plus standard that's required for enterprise software. And furthermore, we have to re-emphasize the importance of the human in the loop. By ensuring a human reviews critical steps, say, before an index GPT recommendation is finalized or before a copilot suggestion is deployed to production, companies bridge that trust gap entirely.
So the core strategy that every successful organization, from JPMC to the successful copilot companies, has adopted is transforming AI from a risky, probabilistic liability into a powerful, controlled force multiplier by maintaining human oversight and strong governance.
That's the winning formula.
So what does this all mean for you, the listener, the business leader, or the developer trying to stay ahead? Our deep dive has fully substantiated the position we laid out at the very beginning. Practical AI, governed, bounded, and assisted, is the profit-driving reality of 2025. Agentic AI is overwhelmingly marketing fiction, a science project that is yet to prove its viability.
The evidence is overwhelming and it's financially decisive. We saw JPMC's $1.5 billion value derived almost entirely from fraud prevention and administrative efficiency.
Right.
We discussed the staggering 95% pilot failure rate directly attributable to the technical limits of multi-step autonomy, specifically the brutal mathematics of error cascading. And we saw the financial alarm bells, proving the economic unsustainability of the hype in that $600 billion capex gap.
The lesson is one of discipline and pragmatism. The market has, it seems, corrected itself.
The smart money is betting on infrastructure, governance, and assistance, not autonomy. The AI employee is still marketing fiction, destined to remain a headline rather than a scalable product. The AI tool, however, is a profitable, reliable business reality that is already transforming how major institutions operate. If you are allocating resources today, allocate them where the risk is low and the ROI is high.
And the final provocative thought we want to leave you with. The ultimate competitive advantage in the next 5 years won't be having the best autonomous agent that attempts to replace human judgment. It will be having the best governed, human-augmented practical workflow.
Meaning the disciplined application of boring technology is the true path to transformation and capital efficiency.
That transformation, based on the numbers, is already well underway. You don't need magic. You just need to follow the proven workflow.